Hello and a warm welcome to Mining Review Africa and DRC Mining Week 2023. Today we are joined by Jochen Willersinn, Technology Manager for Sulphuric Acid Catalysts in Europe, Middle East and Africa at BASF. With the tagline Creating Chemistry for a Sustainable Future, BASF's latest innovations and technologies help reduce plant energy consumption for sulphuric acid manufacturers. Jochen is here to tell us more about sulphuric acid catalysis, key parameters to increase efficiency and lower costs. Welcome, Jochen, and thank you for taking the time to chat with us today.
Thank you very much, Tarren. Good day to all the listeners.
Right, as a starting point, Jochen, can you tell us more about BASF's Catalysts division and the expertise involved that help drive your customers' success?
Yes, exactly. So BASF Catalyst division is basically several parts of BASF. I'm specifically working for BASF Process Catalysts. So I have all of the catalysts that are used in chemical industry, refinery, oil and gas, pharmaceuticals, or transportation. Actually, more than 90% of all chemical products which are produced are using catalysts to facilitate the reactions. BASF Process Catalyst has more than 1,700 employees globally, and we supply more than 800 customers with about 1,000 products. So overall, it's quite a big group within the BASF. And in general, what we are doing, especially in process catalysts, is that we do our best to improve processes with our catalysts to especially remove emissions. So for instance, besides the sulphuric acid catalyst production, we also have catalysts that reduce volatile organic compounds in off gases as well as carbon monoxide, also reducing N2O and NOx in off gas. So we all try to work and to improve the air we breathe and the environment with our catalysts to decrease emissions.
Okay, let's talk more about BASF's new X3D technology. So the technology is based on 3D printing and produces catalysts to help achieve best performance and efficiency while reducing energy consumption. Can you tell us more about this?
Yes. So in principle, all of this X3D and 3D printing technology comes from our big R&D portfolio. So at the beginning, when we started improving our sulphuric acid catalyst, especially, we were thinking about how can we contribute to make catalysts better. And also this involves the journey to our latest big product, which is the Quattro range. We thought that we could use technologies or simulation tools. We could use CFD simulations to simulate how the gas stream is working and moving through the catalyst beds and so on. We could, with this, we can really see and we could prove it with our data we have with the starring, which we're using since the late 90s, how shape and how the design of the catalyst can really improve performance. So with this, we started looking into a new way of making catalysts, because Quattro is actually the maximum you can achieve with the standard line extrusion technique that we're using since forever. And we figured out that 3D printing or micro extrusion was the best way to really modify a catalyst, not on just the X and the Y axis, but also on the Z axis. So you have full control about how you make the catalyst. And this enables a lot of benefits, such as significantly increased surface area while maintaining a very low pressure drop, because you can design the catalyst in such a way that it does not really interfere with the pressure.
Okay, so in what way does this technology offer greater freedom of catalyst design compared to conventional or traditional production technologies?
Yeah, in principle, there's two things. So one thing is that it's custom tunable. So you can really make a catalyst based on your ideas and the benefits you want to see, because you don't have to adjust all of the technology of the techniques like the normal extrusion. You need to have a new extruder, a different extrusion dies. This all takes much time. And with 3D printing, which is a scalable technology and quite easy to perform, you can really just do this within, I don't know, within a week or so, where else other the developments and changing shape takes years. So this is quite fast. And also, in principle, all extrusion catalysts produced by extrusion technologies can also be used in 3D printing, which is quite interesting. It makes us very versatile, very adaptable, and also very fast. Because in principle, you can increase your capacity by just installing more and more 3D printers. So it's a quite valuable technology.
Okay, so and the technology can be used on a wide range of existing catalytic materials. Can you tell us more about this?
Yeah. So in principle, everything that we produce by extrusion processes and calcining processes can be translated to 3D printing, because in principle, our 3D printing technology is nothing else but the extrusion technology, but just on a smaller scale. You don't have the big extruder, but you have a small nozzle. So in principle, you can do all extrusion products you're currently doing with 3D printing. So also something like our styrene catalyst or like anhydride catalyst could be produced with these technologies. So it's very versatile.
Okay, so you have already touched on it, but can you tell us more about BASF's new sulfuric acid catalyst Quattro and its
Yeah.
ability to significantly reduce emissions?
Yeah. So the Quattro is just like let's say the predecessor of the X3D catalyst in terms of how we designed it and how we developed it. For this, we used all the knowledge we had on the styrene, so the old catalyst. And then we used CFD simulations. We used our supercomputer to improve the geometry. And Quattro was designed in such a way that we could maximize the surface area while maintaining the same pressure drop, also making the catalyst much harder in the same time. So the benefit of this catalyst is this significantly increased surface area. This enables, of course, a higher turnover of SO2 to SO3 during this catalyzed oxidation reaction, which in this respect gives, of course, a higher performance, a higher yield of the reaction. And if you have a higher conversion from SO2 to SO3, you, of course, have lower emissions. And yeah, this is basically the story. So the interesting part is that the increase in the surface area can really help to reduce the emissions because the activity of the catalyst is just so much higher.
Okay, thank you. And then finally, Jochen, can you tell us how does this technology enable BASF to provide catalysts that are tailored to your customers' needs? And can you possibly give us an example?
So for the Quattro tailored to the needs, we usually have needs that, of course, new emission regulations turn up in several states and countries, and the customers have to comply to this. So we can actually help them by making a design, making a simulation of how the converter is performing. And based on this, we can look into which catalyst type might be the best choice for them to achieve their goals in terms of emissions, in terms of capacity. And then we choose the right catalyst type. So it's a Quattro, it could be X3D, and we can also choose between our vanadium-based catalyst and also a cesium-based catalyst. Speaking of cesium-based catalyst, we have our 04116 Quattro, which is our highest performing catalyst for the last bed stages. And this is actually the one that really helps to reduce emissions to the minimum level, because it has a synergy effect between an optimized catalyst material and the Quattro shape, which really is boosting the emission reduction to a maximum.
Okay. Jochen Willersinn, Technology Manager for Sulphuric Acid Catalysts in EMEA at BASF. Thank you for joining us on Mining Review Africa and for those valuable insights. And all the best for BASF.
Thank you very much. Have a nice day.
Thank you.